black holes.
Leroy the Science Boy. Leroy the Science Boy. Leroy the Science Boy.
Oh, you may be asking, what is a black hole? Well, a black hole is the rip the space-time continuum. And then you may be asking, what is the space-time continuum? Well, the space-time continuum is like a trampoline. You have different objects that have different masses. So like a bowling ball is like really heavy, so it sinks in the trampoline, making it go down more and having more gravity. And lighter mass, like a ping pong, would not sink down as much. So that's a basic example of you may be asking, what is a black hole? Well, a black hole is the rip the space-time continuum. And now you may be asking, what is the space-time continuum? Well, the space-time continuum is like a trampoline. So you have heavy objects that can sink down farther in the trampoline, and then you have lighter objects that are like don't sink down as much. That's kind of like the space-time continuum. The more it sinks down, the more mass it has, and the more gravity it has. The singularity is the point where all the mass of the dying thing is compressed into little space. And then on the outside of the black hole is a thing called the event horizon. The event horizon is where even light cannot escape from the black hole. So the gravity of the black hole is so much that it's black past the event horizon. So now you may be asking, are there different types of black holes? And if there are, then what are they? There are three main types of black holes. There are your primordial, there are your stellar, and then there are your supermassive. Supermassive black holes are created when they're found in the middle of a galaxy. And so they're created just by the sheer mass of stardust. And then the next one, the middle one, is the stellar black hole. So, a stellar black hole is made by large collapsing stars, and it's the one you normally see on TV. And so the next one is the tiny one, primordial ones. So the primordial ones are the smallest one, and they're only about the size of an atom. So they're really tiny, about the size of an atom, but they're as heavy as large. That's heavy. Made by CERN in the particle accelerator. You may ask now, what would happen if you fell into any one of these black holes, except for the primordial? Those would be hard to fall into. What would happen if you fell into a black hole? You feel a tugging sensation right here, and you're stretching into like a long piece of spaghetti human. You keep on stretching until you snap in half, which is going to be quite painful for you. So after you snap in half one time, you're going to keep stretching and stretching, and then you're going to snap in half 2 times. So you're going to be into 4ths, and then 8ths, and then 16ths, and stretching and snapping and stretching and snapping. So after you fall into a black hole, you're said to not exist. But in quantum physics, it is said that nothing can be lost. And so this sparked a war between 2 science communities, Stephen Hawking and the other guys. Stephen Hawking was like, this can't be true. But then the other guys said, oh, well, it projected, the stuff that has fallen into the black hole is projected on the event horizon. Their theory was pretty solid. They came up with that this theory could be applied to the universe. That there's a projector and then there's the projected. This is kind of freaky, but you don't have to worry. It's not like that. It does not matter if we're the projector or the projected. It doesn't matter to their theory. It could be either, so you don't have to worry. Black holes are a rip in the space-time continuum. There are 3 types of black holes, primordial, stellar, and supermassive. And when you fall into a black hole, you stretch and stretch and stretch until you reach the singularity. And remember, people, don't fall into any black hole.
Leroy the Science Boy.